Hello! For this unit, we're going to be talking about water erosion. There's a bunch of parts in this unit, so you're going to want to pay good attention and go over the PowerPoint before you take the quiz. Alright, so the first part of water erosion we're going to talk about is runoff and its effect due to erosion. So runoff is just going to be water moved from a high point to a low point. So you can think of like the top of the mountain and then creating a stream, which then goes into a river. Things that affect the amount of runoff are rain. Obviously, precipitation is going to affect runoff. Vegetation, so plants hold the soil together. They also absorb a lot of water, so they kind of stop erosion from runoff. The type of soil, so peat is going to be able to be inundated better, which means it can hold more water. The shape of the land, so like the steepness of a mountain, is going to have more runoff than if it's just a flat area. And then how the land is used. So farmland is going to be able to hold a lot more water than, say, like a city street. So for runoff, we start with rills, and then we go into gullies after a little bit of erosion. Then those gullies turn into streams, and those streams turn into rivers. And then streams and rivers are affected by tributaries. So I will show you some pictures of that. So here on the left, we've got some rills. This is like the beginning of a stream, basically. It gets affected by precipitation, amount of soil, amount of vegetation, all of that stuff. And then if it gets enough precipitation and it has the right kind of soil and it erodes this area enough, it's going to start to create a valley, and that's going to be a gully. So you can find these places everywhere. And then that gully is going to get more precipitation. The runoff erosion is going to happen a little more, and it's going to create this huge valley area. Rivers create V-shaped valleys. Glaciers create U-shaped valleys. That's something to remember for the test. But with that valley, then we're going to get a stream and a river right here. You can see that happening right there. And then this river right here, if you follow my mouse, is the main river area. But all of these little pieces here, these little streams going into it, those are called tributaries. So these tributaries feed into the river and make it larger, increase the volume of water, that type of stuff. And those are in pretty much every water system. So, erosion by rivers. It's dependent on the speed of the water. If you've got fast-moving water, then it's going to erode the banks a lot more. Slow-moving water doesn't really have a crazy erosion effect. It will still create erosion, but not as much as a fast-moving water area. And then if you remember from our first subunit in weathering, we talked about differential weathering, and that's when soft rock gets eroded and leaves hard rock. That's what waterfalls are, basically. This water area, it keeps crashing on this soft rock and hard rock base, basically. It weathers away that soft rock. When that soft rock is gone, all that's left is the hard rock underneath, and then it falls. And so waterfalls are just when water is falling. So, erosion by rivers, we also have floodplains. So that's when a river gets too much precipitation or too much water. It's going to overflow onto that shallow land on either side of it. So you could think of like the Nile, that whole Nile River. There's a bunch of floodplains like in Egypt. And then we've got meanders, which are caused by differences in hard and soft rock as the water goes. When it hits hard rock, it's going to kind of take the path of least resistance. It's going to look for an area for softer rock. And so the river just kind of like goes like in a little snake pattern. And then with meanders, we get these strange effects called oxbow lakes, and I'll show you a picture of that. So here, this is a really great picture of not only a floodplain, but also oxbow lakes and meanders. So this water is going to go from somewhere. It's going to be, it's going to get some runoff. It's going to start going, and then right here, it's hit an area of hard rock, so it turns. It finds another area of hard rock, and it turns. And so it keeps doing this. It's finding the path of least resistance, essentially. So This little tan area, that's going to be softer rock, and that brown area is harder rock. So oxbow lakes are when the meander gets cut off. So eventually this river is going to erode this hard part enough to where it will just kind of cut this side off, and then it will just go straight into this other part of the river and then continue on its way. So that's what happened over here, is this river kind of went like this. It came all the way over to the left and went right back around. But essentially right here, it stopped that turning process. It weathered away enough to where it could just connect with the other part of the river. Then you can see around it, we've got a floodplain up until you get to this green part. That's going to be like a mountain or higher elevation. And these streams are tributaries, so they go down from the mountains as runoff, and then they enter this little teeny stream, this Yazoo stream, and then somewhere the Yazoo stream is going to get into this meandering river as well and create another tributary. So here's an example of a floodplain. These are usually seasonal and cyclical, so we can kind of tell when they're about to happen. All right, so we've got deposits by rivers next. We talked a little bit about alluvial fans in the first subunit, and essentially it's just a steep drop-off to shallow land. Really what that is I'll show you a picture, but it's just where a lot of sediment gets deposited at the bottom of a mountain. Essentially, alluvial fans are deltas just without the water. So deltas are when a stream or a river runs into a large body of water, and it also deposits that sediment. It creates kind of a marsh effect. You're going to see a lot of like long-legged birds walking around in there. It's kind of a swampy looking area. And then we'll talk about soil on floodplains a little bit. Rivers, when they flood, they deposit a bunch of soil on the outside of the floodplains, or outside of the river onto the floodplains. And that's kind of that natural erosion process we talked about, how it kind of creates new nutrient-rich soils for plants and animals to thrive on. Okay, so here is an alluvial fan. We've got the runoff from the mountain. It's bringing down sediment from the mountain due to erosion and weathering. And then eventually it hits an area where it's not moving quite as fast, and that sediment gets deposited. So sediment is deposited when it either hits a block or it stops moving as quickly. Here is an example of a delta. We've got this river going along here. It hits an ocean, and then when it hits that ocean, it's not going quite as fast, and so it deposits the sand right in here. And this is going to be relatively nutrient rich. It's a really good ecosystem. All right, let's talk about groundwater erosion. So when we talk about groundwater erosion, usually we're talking about the formation of carbonic acid, and that's just carbon and water. So dead plant material a lot of the time, like leaves, stuff like that, those hold carbon. When water hits them, it creates a slightly acidic solution called carbonic acid. And then when that carbonic acid hits something like limestone or sandstone, that's going to chemically weather away that conglomerate or that sandstone area. And we're going to get cave formations with stalactites and stalagmites. And then this formation of karst topography, which is like little caves and sinkholes underneath the surface of limestone deposits. So a lot of Florida has karst topography. When you hear about sinkholes, essentially that's when carbonic acid is hitting the underlying rock, which is limestone. That limestone gets a crack in it or a hole in it, and then you build houses on it, and those houses, all that weight kind of pushes down, and then also with the force of gravity, and that pressure is going to create a sinkhole, and it's just all going to collapse. So by building in Florida, it's kind of silly because Florida is not only it's a swamp with a lot of carbonic acid in there. Swamps are normally acidic, but also underneath the bedrock is limestone, so it's not really that great of an environment to build on. So here's a cave. We've got stalactites at the top, stalagmites at the bottom. They're not really in this cave. There's a couple here. This was formed by just inundation of water, which means water was there for a long period of time. And then here is an example of karst topography. So that water It hit some sort of carbon material. It created carbonic acid. When it fell down and infiltrated the sides of these caves, it weathered them away and made larger holes in caves in the side of this mountain. So that's karst topography. Um, it can also happen where you can't even see it, and that's when you're going to get a sinkhole. So waves are also water erosion. So they are normally caused by wind, or it's only caused by wind, and the energy transfer is essentially the wind goes across it. The water particles are just moving up and down at an excited rate. They don't move over, but as the wind moves over, it's going to move the water as well. And with that excited process of particles in the water, it creates more energy. So that energy is going to continue on its way. And then we've got the formation of drag, and that's basically when that wave hits kind of a shallower area. It creates like a bigger wave, but it's really losing a lot of its energy, and that's what drag is. So here, we've got that energy transfer here. We've got wind pushing the waves or the water over. Those H2O particles are moving up and down at an excited rate, creating more energy in the system. We get a swell, and that swell is going to hit the ocean floor. It's going to slowly lose energy as it moves up. The local winds are going to push it out, and then that's when you get that backwash effect. So the wave comes in, it hits this area, and then it goes right back out. So erosion by waves, normally it's just the crashing of the waves into the land, but also if the wave is carrying sediment, that's going to have like a sandblasting effect, so that also causes erosion. A thing to know is what a headland is, and a headland is just a piece of land that juts out into the ocean. It's another process of differential weathering, where it's like harder rock left behind from softer rock on the other sides of it. So when you think of like peninsulas, that's going to be an area of harder rock. And then we've got some cool landforms created by waves. We've got sea stacks, sea arches, and sea caves. So right here is a sea stack. It got weathered away on the sides. That differential weathering left the harder parts up top. A sea cave down here, same process is happening. And this is a little bit of karst topography as well. And then a sea arch where either there was too much pressure from waves hitting this area directly, or this area was subject to differential weathering where this was softer rock and this is all harder. Okay, so we've got deposits by waves. We've got beaches. Beaches are just the deposits of eroded material from the ocean, but also an effect is called longshore drift. So when waves hit the shore at not a 90-degree angle, it kind of drags that sand with it sideways. We've got spits. When the land curves, longshore drift kind of keeps going. It creates this like area of sand. I'll show you that. And then we've got sandbars and barrier beaches. When there's too much sediment in the water and it gets deposited before it hits the beach because it's just too heavy and the waves aren't powerful enough. So right here we've got a sandbar. So you can see it didn't quite hit the beach. It got deposited right before the beach. It's just kind of sitting out here in the middle of the ocean. We've got a reef right here that kind of helped with that as well. And right here we've got a spit, so that longshore drift is going to pull the sand this way as the waves bring it down this way. We get this weird little formation of sand on the end there, where there's a lot more sand here than there is right here. And then I think that might be it. Looks like that's it. All right, so if you have any questions, comments, concerns, you can call me, text me. Other than that, have a wonderful week.